Welcome to Mathematical Practice 5. Use appropriate tools strategically. Remembering that these standards are for our students, the question is, can our students use appropriate tools strategically? For students to do this, they need to reach the following 5 goals. Number 1, students will access and choose the just right tool for the task. When approaching a problem, students ask, what is the right tool for the job? What tool will help me to find out what I want to know? What tool will help me to show what I think is true? Number 2, students will use a variety of developmentally appropriate tools. As teachers, we consider the grade level and what students are capable of using at that grade level. Often this requires that we look at the grade level standards and the standards for later grade levels. For example, more than once I've witnessed teacher candidates expecting kindergarten students to use a ruler to measure inches, whereas a quick look at the CCSSM shows us that rulers are introduced in grade 2. Now, this is not to suggest that no kindergarten or grade 1 student should be taught to use a ruler. It simply means that many, maybe even most, students will not be developmentally ready to use this skill until grade 2. Number 3, the third goal for this mathematical practice is that students will recognize the power and the limitations of various tools. In a messy life context with many tools available, we need to consider which tools are powerful in a situation and which are limited. Rather than using the same tool all of the time, we consider which tools are most helpful for solving particular problems. As teachers, we plan for situations where students will need to decide which tools to use, and through using these tools, they discover which are the best to use, which are the most powerful. In other words, which are the fastest, the most accurate, which makes the most sense in a particular situation, and which do not help to determine what we need to know. The fourth goal for this mathematical practice is that students will know how to use various tools appropriately. Students may, for example, attempt to use paper clips to determine how long their hand is. But if they use that tool inappropriately, they will arrive at an inaccurate conclusion. In order to use technology and tools to make sense of mathematical ideas and to help reason mathematically, students need to know how to use tools appropriately. The fifth goal is that students would learn to use tools and technology, which is a type of tool, to communicate their mathematical thinking to others, and as we discussed in Mathematical Practice 3, through that communication, they will clarify their own thinking. So, in this module, we will discuss each of these CCSSM goals. Use appropriate tools strategically. As this class poster suggests, our goal as teachers is to guide students to the conclusion that, as the poster states, I can use math tools to help me explore and understand math in my world. That students would know that they have a math toolbox, a variety of math tools that they might use, and that it's up to them to decide which tool makes the most sense in a given situation. The 8 mathematical practices. You may be thinking, there seems to be a great deal of overlap in these standards, and you would be right. Standard 1 spans and is foundational for all of the other mathematical practices. In Standard 2, we talked about the connections between abstract thinking, numbers, and real situations, problems. In Standard 4, we explored modeling math ideas, and again mentioned abstract thinking and real situations. And in Standard 4, we talked about using models to show math concepts. As we continue to explore the mathematical practices, we will continue to see these overlaps. Or better yet, we will continue to see this integration. If we attempt to place each of these standards in a separate compartment, we could easily become frustrated and confused. It's good to know that through each practice, intermingled with the others, as we put each into practice, we will notice that each practice has a unique focus. Rather than trying to compartmentalize mathematical practices, think about blending the practices to empower your students to use math and to think mathematically. Why focus on tools? Well, mathematicians use tools to do their work. When we perform calculations, we decide if we should use a paper and pencil algorithm, or if we should grab a calculator, or if mental math is best for working through to a solution. When we measure, we must determine which tool we're going to use and which unit of measure makes the most sense for the task. For example, if we want to paint a wall, should we measure the length and the width of the wall in inches or in feet, in centimeters or in meters? Will we use a ruler or a tape measure? That all depends on the size of the wall that we're measuring. And when we go to the paint store, would it be more helpful to bring the measurements in feet or in yards? Consider also when we're arranging furniture to fit in a room. Do we grab a blank piece of paper, or do we choose grid paper to create a model of our floor plan? Or do we just move the furniture around to see if it fits, and if it doesn't, rearrange it another way? As users of mathematics, we're familiar with a variety of tools. We're able to determine which tool makes the most sense for a given task, and we can effectively use tools to perform that task. Understanding Standard 5. Mathematics is active. The ability to select and use math tools is essential for our students' success. Whether they're counting cookies, adding quantities, measuring the length of their desks, or calculating how much a book weighs, our students will meet with greater success if they can identify the appropriate tools to support each task, and if they can effectively use those tools to perform the task. While we may think of tools as math devices, like rulers and calculators, the CCSSM has a much broader definition of tools. Tools are that which supports students in the performance of a task. Concrete materials like connecting cubes, buttons, grids, number lines, and fingers are all tools. We classified some of these in Mathematical Practice 4 as models, but they can also be classified as tools when they help us to perform tasks, find solutions, or solve problems. Tools enhance our students' mathematical power. Mathematically proficient students decide when to use tools, select appropriate tools, and use the appropriate tool accurately. Select appropriate tools. Primary students might select tools like colored bears, buttons, and number lines to help them solve math problems. What might they use to solve a problem like, some students are in the kitchen center, some are in the book center? To count up how many of our friends are at the center and how many are in the book center, will students count the number of friends and then represent those friends using cubes? Will they use an abacus? Will they use a 10 frame and counters? When students determine which toy is the longest, what tools will students select? Will they compare lengths using tiles, Legos, a ruler? There's often more than one tool that will work for a task, but some tools are more efficient than others. And as students develop in Mathematical Practice 5, they become more proficient in deciding which tools will best meet their needs. With each grade level, additional tools are introduced. Should students measure weight using a balance scale or a bathroom scale? Which will give them the most useful information? When solving a problem, should students always use an algorithm? When are paper and pencil algorithms the best way to solve a problem? When might a calculator be better? When is mental math quicker and easier. The ability to choose the appropriate tool is an important reasoning skill, and Mathematical Practice 5 focuses our attention to the need for teachers to help students develop this important skill. 17 plus 4. How would you solve this equation? See if your method is similar to one of the methods children in O'Connell's study used in his research in a first grade classroom. In that study, on the board, the teacher posted the equation 17 plus 4. She asked her students to think about the answer and think about how they got the answer. After a few seconds, she asked them to turn to their partners, whisper the answer, and explain how they got the answer. She listened as they shared. Then she asked students to share as a class. Megan said, "I wrote the numbers down on my paper. I put 17 on the top of 4, and then I added the ones, and I got 11. So I wrote 1, and then put the other 1 in the tens place. Then I added the tens. I got 21. Let's think about it. What method did Megan use?" Megan used the traditional paper and pencil algorithm to find the answer. The teacher asked, "Did anyone do it another way?" Cookie said, "I got 21 too, but I just started with 17 and counted on 4. Did you write it on paper?" "No," Cookie said. "Why not?" Cookie said, "I just added on. I didn't need to use the algorithm." What method did Cookie use? Cookie used mathematical reasoning to start with the larger number and then count on. Belle said, "I didn't use paper. I just knew 7 plus 4 was 11, so I thought, it's just 10 plus 11, and that's 21. What method did Belle use? Belle might have used her understanding of combinations, of which numbers added together will equal 10, and then used 10 plus 1. Or Belle might have known immediately that 7 plus 4 is 11, and then added 10 plus 10 equals 20 plus 1 equals 21. We would need to ask Belle to tell us more to determine the exact method she used. The teacher asked, "Does that make sense?" And Ezra answered, "I didn't do it like that. I just thought you need 3 more to make 20, and then you would have 1 left, so that's 21. What method might Ezra have used? Ezra might have used his understanding of combinations to make 10, and of counting by tens. Teacher, so you could have used paper and pencil, but you also could have done it in your head in lots of different ways? Betsy said, "Yes, I could use paper, but it was faster in my head." Many of these grade 1 students recognize the value of mental math as a tool for solving that particular problem. Our students are constantly faced with decisions about which tool will help them to complete the math task. Can they select the appropriate tools? The tools that make the best sense for the various tasks? Can they choose the best physical tools? Can they select the best computational tools or mental tools? Can they select the most efficient tools? Our students benefit from opportunities to select a tool that makes sense for the math task and to evaluate which tool is most efficient for that task. Use tools appropriately. Not only do our students need to be able to select appropriate tools, they must be able to effectively, appropriately use those tools. When Ava's friend says that his rock weighs more than hers, and Ava grabs a balance scale to find out which rock actually is heavier, Ava has chosen a tremendously helpful tool. You may be thinking, what if Ava doesn't use the balance scale correctly? She could end up with an incorrect result. If you thought this, you would be considering another aspect of Mathematical Practice 5. The chances of error are high for students who lack skill with the tool or for those who do not use their number sense to check the reasonableness of the answer generated by the tool. Do our students check their answers for reasonableness? For example, consider the number line. Do students know how to use number lines? Do they know where to begin on the number line? Do they know what direction to move in if they're adding, if they're subtracting? Do they know why they move in that direction? Do they know how to determine the quantity for each jump? Linear measurement, measuring length pre-K to kindergarten. According to the CCSSM, pre-kindergarten and kindergarten students are to learn to think about length in terms of attributes. Students in these grades are to learn to compare lengths of various objects to determine which length is longer, shorter, the same. The learning we teachers need to focus on when teaching pre-K to kindergarten are as follows. Do students know that length is the distance between 2 points? The distance between the beginning and the ending of what is being measured. Do students know that when they compare the lengths of objects that they need to line the objects up so that the beginning points are at the same place? Do students realize that the object being compared needs to be in a straight line in relation to each other? Do they realize that the longer object extends beyond the other object? Do they realize that the shorter object does not extend as far as the longer object? Do students realize that when objects line up and have the same starting and ending points, that they are the same length? As with all content standards for a particular grade level, we teachers need to know the concepts that students are to learn for that grade level. Many authors talk about this as unpacking the standards. When teachers determine the concepts inherent in each standard, they are unpacking or decoding the standards. We will do our own unpacking of standards later in the semester. Linear measurement, grade 1. Building on the strong foundation built in pre-K to K, students know what length is and they understand how to compare lengths. Building on that foundation, grade 1 students learn to not only compare, but to measure length. Before students learn to use standard units of measure, like inches on a ruler, in grade 1, they learn to measure using non-standard units. In grade 1, students learn to measure using tools with non-standard units, such as numbers of links on a chain, as we saw in the video probe for this lesson. When you're teaching grade 1, provide students with a variety of non-standard tools for measuring length. For example, give them cubes that they can link together, paper clips to link together, Legos to link together. Notice that in grade 1, measurement begins with the use of tools that either are linked together or that can be linked together. When students use these tools, ask, do students know that one block or one link or one Lego or one paper clip is 1 or 1 unit? What is 1? Knowing what 1 is essential for determining how many of those ones we have, or how many ones long something is. Do students know that when we measure, we're counting how many ones unit long something is? Do students know the longer the unit is, the fewer number of units long something is? Consider the pencils in the bottom left. When we measure a pencil using short paper clips, the pencil will be 5 paper clips long, whereas if we measure how long the pencil is using large paper clips, the pencil's 3 paper clips long. The larger the unit, or the 1, the fewer number of units are found in the measure. Do students know that the unit needs to remain the same? For example, all of the paper clips in a chain need to be the same size. You can't measure the number of paper clips long something is using a mixture of short and long paper clips in the same chain. Do students know that once they choose a unit, once they choose what 1 will be, that they need to continue to use that same unit throughout their measuring task? When students are first learning to measure using non-standard measuring tools, we teachers need to provide numerous measuring tools for students to choose from. Tools that have the same size units linked together or that students can link or join together. Once students have learned the basic concepts of measuring accurately, they will be ready to use more advanced measurement tools. In grade 1, students learn another important skill, and that is to iterate. Iteration. Once grade 1 students understand how to determine length using non-standard units, once students know how to appropriately measure using units that are joined together, they're ready to learn what in math is called iteration. Iteration means to repeat a process. In measurement, this means that students repeat the counting of ones by moving the unit along what is to be measured to find out how many units, how many ones long something is. When we measure something that is longer than our measuring tool, we need to iterate the unit. That is, we need to repeat the process of counting ones by moving the unit. Sticks or any other 1-unit measuring tool can be used when we start to teach grade 1 students how to iterate. We teach iteration by using units that are not linked together, units that need to be moved to find out how many units long something is. A 1-unit tool is then laid straight up against that which is to be measured. When they iterate, we ask, do students know that the first unit needs to begin at one end of what is to be measured? Do students know that the next unit needs to start right where the other unit ended? Do students know that all units need to be laid straight up against what is to be measured? Do they know that units need to be laid out all the way to the end of what is to be measured? Do they know that how long something is the total number of times that 1 unit is laid or moved along the object to be measured? Common misconceptions. All topics have potential for misconceptions. Here are pictures to show some common misconceptions grade 1 students develop when they're measuring length. See the left side of the slide. Students don't realize that the units in the series of units need to be the same size. See the top right. Here, students fail to line the units up straight against that which is being measured. In the bottom right, the first example, a student has chosen to measure the length of a picture frame with equal-sized paper clips. By iterating the paper clips correctly, the student finds out that the frame is 6 paper clips long. Notice that the paper clips are lined up end-to-end with no gaps between them, and I would add, no overlapping of paper clips. In the next example, to the far right, a student is not iterating correctly. There are gaps between the paper clips, so the entire length of the picture frame is not being subdivided correctly. This causes the student to measure the length of the picture frame as 5 paper clips. I would add, if the student had overlapped the paper clips, the length would have been more than 6 paper clips, depending upon how much overlapping took place. As the standards stated, no gaps and no overlaps. Dealing with misconceptions. Your students will come to class with their own notions of how things work. When those notions conflict with reality, we call them misconceptions. Sometimes misconceptions form from a student's past experiences, sometimes from incorrect or incomplete teaching. Often the cause cannot be identified. Regardless of the cause, there are strategies that we can use to address and help students to correct their misconceptions. These strategies are supported by research. If you're interested in the research, see the list of references in the last slide. The strategies suggested on this slide are research-supported strategies that apply to most, if not all, misconceptions. Number 1, pose questions. To address students' misconceptions, we need to know what those misconceptions are. Richard, Church, and Morrison's research show that asking questions like, "Why do you think that?" and "Tell me more," helps students to verbalize their thinking. And when we know what students are thinking, we can watch for puzzled responses. Number 2, maintain a safe environment. Maintain a safe environment for reflection and discussion. As was discussed in Mathematical Practice 3, a safe environment encourages students to construct viable arguments, to reflect on and critique their own thinking, and to build evidence-based arguments. In addition to posing questions and maintaining a safe environment, have students construct arguments for their conceptions. When they cannot defend their thinking, students begin to question that thinking, and having questioned themselves, they are then open to changes in thought. They realize that the goal is that their understanding would be supported by evidence, and that they need to convince others using evidence-based argumentation. So pose questions, maintain a safe environment, and have students construct arguments for their conceptions. And the fourth strategy is model with mathematics. Now, in Mathematical Practice 4, Model with Mathematics, we talked about how it also helps students to address, to show their thinking. And in this, as a tool and as a means to overcome misconceptions, this helps students to overcome their misconceptions, especially when they model their thinking to one another, only to discover that their reasoning does not match that of their peers. As they compare and contrast among models and reason with models, students address and come closer to overcoming their own misconceptions. Using multiple models is important, as conceptions need to make sense up and down the ladder of abstraction. Remember that ladder? From real situations, through drawings of real situations, to concrete objects that represent real situations, to drawings, through to abstract numerical representations, up and down the ladder of abstractions. Now, though all mathematical practices are important for addressing and overcoming misconceptions, mathematical practices 2, 3, 4, and 5 are especially powerful. Linear measurement, rulers. If the pre-K to grade 1 teachers helped students to learn the basics, grade 2 students will be ready to expand beyond their foundational understanding to then begin using traditional measurement tools. As we consider concepts grade 2 students are to learn, we ask, do students know where to place the ruler in relation to the object to be measured? Do they know that they place the measuring tool in a straight line up against the object? Think about rulers and where 0 begins, where the markings on the ruler begins. In some rulers, the markings begin at the end of the ruler, whereas in other rulers, there's a space between the end of the ruler and the first marking. We ask, do students know that if the markings begin at the edge of the ruler, this is where they line the ruler up to the object? And do they know that if there is a space before the markings begin, do they know that rather than lining up the end of the ruler to the end of the object, they need to line up the beginning mark up to the end of the object? We ask, do students understand that length is the difference between any 2 points on a ruler? That length is not just the distance from 0 to another point on the ruler, but that they can measure between any 2 points on the ruler. Do students know how to iterate when measuring something longer than the ruler? Do they know that they need to mark where the markings end on the ruler, and then move the ruler so that the 0 point on the ruler lines up to the place they marked, with no gaps and no overlaps between the mark where the ruler ended and where the markings begin. And so it is with all tools. The concepts students learn in pre-kindergarten to grade 2 support students' understanding of math tools in general. And in these early grades, students learn how tools are used to build understanding and express understanding. Throughout the grades and throughout math topics, different tools are added to the student's toolbox. Nonetheless, what students learn about tools in pre-kindergarten to grade 2 will build the foundation for the use of tools throughout a student's life. Summing it up, the ability to select and use mathematical tools is essential for our students' success in mathematics. While there are many tools that support our students as they perform math tasks, our goal as teachers is to help students become competent in determining tools are most efficient for specific tasks and how to use those tools strategically, correctly. Here are some comments by students and what they think about mathematical tools. Stella, a kindergarten student, said, "We can use our fingers as tools to find answers. They're great because we can always find them." Andrew, a grade 1 student, said, "You can use one tool to do a problem and then use a different tool to check your answer. I like to use the number line to check my answers when I add and subtract with blocks." Sonia, a grade 2 student, said, "Tools are everywhere. We can see and use them at school and home and at a friend's house. Base 10 blocks are great. Math games can be tools, and I sometimes go online to find out things in math." Use tools strategically. When students practice Mathematical Practice 5, they choose the just right tool for the task. They use a variety of appropriate tools, recognizing the strengths and the limitations of each. And they use the tools appropriately to make sense of math and to communicate their thinking in math. Transfer your learning. To give evidence of learning, complete Mathematical Practice 5-3 transfer. Use appropriate tools strategically. In this transfer, you will use what you've learned in this module to teach students what the Common Core State Standards for Mathematics expect students to learn about tools for the grade level of your tutees. For our next topic, we will study Mathematical Practice 6, Attend to Precision. Before moving on to the module for Mathematical Practice 6, complete the probe. I hope you will continue to enjoy learning the mathematical practices and what they mean for teaching our students and equipping them for learning. All the best.